Alright, in this video, there's a shorter video. The last one was meant to give a crash course on all the coding, trying to answer the common questions that I've heard during office hours. This is a slightly different video. I'm going to assume you have looked at the previous video or that you visited office hours and gotten questions about the code answered. The thing I think to do really is to try to understand the code really as is. And if you understand what's going on with the code, so I may have modified this code. This code might not look exact like from earlier. In fact, I have, right? This used to say 20 originally, but now says 30. The thing is, if you really understand what the code is doing, then you should, make small changes and go, I wonder what happens if. So I changed the x value to be x value plus 2 instead of plus 1. And see if you really understand what's going on, conjecture what you're going to see when you hit run. And I think I'll see x value 3, 5, 7, right? So you can really check if you really understand what the code is doing. It's too easy, it's too tempting to just want to take either example 1 or example 2 and just try to tweak it enough to make it become Simpsons rule. But I almost think it's these two codes are trying to show a lot of what's going on. They're trying to illustrate a lot of things, and I think you'll be better off almost if you start from scratch. Now, you may or may not choose to do that, but I want you to understand each of these two example codes for what they are, as opposed to just necessarily saying, how come you did it that way? That's not what Simpsons rule does. Again, I'm just trying to show what this thing can do, right? And so you've got to think of how to do modifications. And if you want to go back to something else, fine, print a lot of information on screen. I'd like to use this video to talk about sort of some common errors, things that you can look at. So first of all, make sure, and sorry about this, but the capital dot ends could be lowercase dot ends in both codes. In the second code, I left out a function f, but you can make one, use the one that you need or something like that. Otherwise, make sure indentation, right? All these are indented at exactly the same level. Same thing in the next bit of code. This right here, there, this, that. These are all indented exactly the same. Then the next indentation levels are all exactly the same. So, for instance, this code the computer is not going to be happy with. If this is just like that, also not happy for the computer, right? So everything should be indented at exactly that same level if this is all one block inside, right? The other things to sort of be careful of is it's easy to accidentally do things like have sub here instead of subs, right? These control structure lines, like right here, right at the end of this while line, there's a colon here, there's a colon here, there's a colon there, there's a colon here, colon there, colon there. Though, in your print lines, you've got like text here in double quotes all the way through, that's good. And then after a comma, then this is, a thing that the computer would normally understand. It's like a thing you could normally add to something else. Then a comma again, and then in double quotes just some text, and then a comma. So notice, I've always got, if I want, I can have comma separate. Oh, I don't know what just happened. Let me undo that. But like I can have, text in here if I want, and I can run that. Right? So this one, yeah. So you can have text in double quotes, comma, and then text again in double quotes. But you've got to make sure to have commas between things if you're printing several things all on one line. So you've got to, be very kind of attentive to some of the detail surrounding this sort of thing in the code. The key thing I would suggest that you do is the author of the book does have 2 examples of Simpsons rule being done using different functions and using different values of a and b. I would suggest that you go through and, I think one of those functions, just off the top of my head, I believe it's like a 1 over x, maybe that interval is from 1 to 2. See if you can actually maybe not worry too much about, is your code doing Simpsons rule for the writing assignment? Well, of course that's important. I think it's good to take a step back for a moment and, since there are examples in the book that are thoroughly done with Simpsons rule, and you can do those same examples by hand, take a calculator out, and print a lot of information on screen. Make sure that the information shown on screen is exactly what you think should be shown on screen. And maybe you have to modify things like this less than, maybe you want, x value less or equal to. You've got to decide some of these sorts of things. Maybe you don't want to have x value up here. Maybe you want to have something like, I is less than n, or something like that instead. You've got to make some decisions about, what's your criterion for why you want this section to continue to run. And as soon as this is false, the computer will come down and just print this, whoops, we'll print this line down here instead. So you've got to make some decisions related to this, and I think the best thing you can do is to really, you know, just carefully first create not necessarily Simpsons rule for our project, but really make it work for the two examples of Simpson rule. And again, printing a lot of information to screen is your friend. If you're really unsure what's going on, you might even, before this stuff runs, you might choose to have something like print the value of I, which represents the interval number, is, and then just show it on screen, right? You know, just, you know, and then you can see which part of this thing that you're tracking through, right? So you can get a lot of information on screen if you want, and I think from the earlier video I had commented out a bunch of print lines, and I want to bring them back in so that I have a lot of information. And you know, this, since there's a lot of different print lines within this loop, having this, you know, this line full of dashes to help separate all of this was from one run of the loop, and this was all one run through the while, this portion here, you know, print a lot of information on screen. You know, check your numbers. Check numbers like this and make sure that the a number like this that you see is exactly the same as what you did by hand when you did Simpsons rule. And if so, then everything ought to work out.